हेलो डियर स्टूडेंट्स, अस्सलाम वालेकुम। सो वी आर विद न्यू सेशन, ठीक है ना बेटा। तो पहला लेक्चर हमने ऑलरेडी दिया है बेटा, ओके। सो ऑन द ग्रेविटेशन, ठीक है बेटा, ओके। सो दिस इज हाईली नीट ओरिएंटेड, ठीक है बेटा, ओके। सो इट मे बी डिफिकल्ट फॉर द क्लास 11 स्टूडेंट्स ऑब्वियसली, ठीक है ना बेटा। द रीजन इज दैट स्पीड इज अ बिट फास्ट, ठीक है बेटा। We are not going for the mathematical derivations, ठीक है बेटा। That is why it may be a bit difficult for the class 11 students, but for the class 12 students I am sure they can easily understand it, ठीक है ना बेटा, number one. And number second is that the students who are the NEET, it is highly this useful, it will be highly beneficial for them, okay. So they can take the help from here, ठीक है ना बेटा, okay. तो चलिए बेटा, आज जो हमारा नया टॉपिक है वो है ये, दैट्स एक्सेलरेशन ड्यू टू ग्रेविटी, ओके। सो हाईली इंपॉर्टेंट टॉपिक है बेटा, ठीक है ना बेटा। कंटिन्यूअसली क्वेश्चन इज आस्क्ड फ्रॉम हियर। अगर हम पूरा ग्रेविटेशन देखेंगे, सो इफ विल एनालाइज फॉर एग्जांपल लास्ट 2-3 इयर्स पेपर्स, ठीक है ना बेटा, तो आप ये देखोगे at least 2 or 3 questions are asked on consistent basis from the gravitation, ठीक है ना बेटा, okay. Moreover, if for example you go for the gravitation, okay, you master the gravitation, then in that very case you are almost done with the 90% of the electrostatics as well, okay. It's going to help you in the electrostatics as well, ठीक है ना बेटा, okay. So let's get started. So जो बेटा आज का टॉपिक है, that's the expression for the acceleration due to gravity. I am sure आपको acceleration due to gravity already पता होगा. Acceleration due to gravity simply implies it is that acceleration with which a particle is accelerating towards the center of Earth, isn't it? Okay, ठीक है ना बेटा, okay. So let's try to derive the expression for the acceleration due to gravity. All right. तो यहाँ आप ध्यान दीजिए बेटा. So what we are going to do is that we are going to switch the acceleration due to gravity, ठीक है ना बेटा, okay. So let's start here, acceleration due to gravity. All right. So here let me write it down first of all. Wait a moment. Okay, so let's start the topic, and that's acceleration due to gravity, ठीक है ना बेटा. So in short form I can write like this: ADG implies acceleration due to gravity, ठीक है ना बेटा, okay. Important topic, ठीक है बेटा, okay. So first of all, for example, let's suppose that let's assume that this Earth, ठीक है ना बेटा, let's assume that this Earth, okay, and what's given to us is that its radius is equal to capital R, जो इसका mass है बेटा that's equal to capital M, ठीक है बेटा. Capital M is the mass of the Earth and R is the radius of the Earth. All right. Now we have to calculate acceleration due to gravity on the surface. So let's try to calculate the acceleration due to gravity on the surface. For that, what I will assume there is that there is a particle whose mass is equal to small m on the surface of Earth. All right. Now obviously on this particle there will be a force, and that force is gravitational force, and that force will be given by the Newton's law of gravitation. ठीक है ना बेटा? Okay. So simply the distance between the center of this particle and the center of the Earth is equal to capital R. तो बोलो बेटा force किसके बराबर आएगा बेटा? Force will be equal to what? Force will be equal to F, ठीक है ना बेटा, is equal to G multiplied by capital M and small m divided by R square. All right, ठीक है ना बेटा. And then I will equate it with this. I will use the Newton's second law of motion. So it's equal to mass into acceleration. बेटा जो यहाँ पर acceleration है, that acceleration is of course due to the force, but the force here is gravitational force. So that is why we label it as G, ठीक है ना बेटा. So I will write it here m multiplied by g. By g is the acceleration due to gravity. This m and m will obviously cancel like this. So we are left with this, that acceleration due to gravity is equal to gm divided by r square. ठीक है ना बेटा, gm divided by r square. ठीक है बेटा. Then you know that the mass of the Earth is equal to what? That's equal to 6 into 10 power 24 kilograms. Then you know that the radius of the Earth as well 6.4 into 10 power 6 meters. ठीक है बेटा. On substituting the values, then substitute the value of g as well. So finally you'll get the answer, this magical number here, and that's 9.8 meter per second square. Or approximately we take it 10 meter per second square. For problem solving we take it 10 meter per second square. ठीक है ना बेटा? Okay. So this are important equation, that the acceleration due to gravity on the surface of Earth or close to the surface of Earth, one and the same thing, on surface of Earth or close to surface of Earth is taken as what? gm by r square, which is called 9.8 meter per second square. ठीक है ना बेटा? So the important equation here we have in our hand is this, that is g is equal to gm by r square. ठीक है बेटा. So let me tell you something important here. ठीक है ना बेटा. So that is this equation, this gm, capital G capital M is equal to gr square. ठीक है ना बेटा, gr square. Okay. So this is really highly important equation. If I will not exaggerate, this equation will be at least repeated 5 or 6 times in the gravitation. This equation that gm is equal to gr square. ठीक है ना बेटा? With time you will see that this equation will be repeated again and again. Okay, so what we have is this acceleration due to gravity on the surface of earth is what? That's equal to gm by r square. Okay, so here we have g is equal to gm by r square. Important equation gm by r square. ठीक है ना बेटा? Okay, ठीक. Now next thing beta, that's we have to calculate the value acceleration due to gravity in terms of density. Okay, you must know how the acceleration of gravity varies with the density of the planet. All right, so easily we can do that. Okay, so here I will write down g in terms of g in terms of density. And let's say that the density is equal to rho. Okay, this is the density of the, not the density of the object, it's the density of what? It is the density of the planet. ठीक है ना बेटा? All right. So for that, what I will do is this. Let me first of all define this density. Density होता क्या है बेटा? It's equal to mass per unit volume. Is that it? It's equal to mass per unit volume. Now this equation implies that if you want to calculate mass, बोलो बेटा mass किसके बराबर होगा? Rho multiplied by v. Okay. So mass is equal to rho multiplied by v. Wherein this rho is what? It's the density of the planet. And what about this v? V is the volume of the earth. Okay. Then what we assume is that this volume of the earth is this earth is spherical. It is spherical, okay, but in real sense it's not exactly spherical. It's what we call this, it is ellipsoidal in the shape. It's ellipsoidal in the shape. ठीक है ना बेटा? The polar radius and the equatorial radius are not same. There is a small difference of 21 kilometers between the polar radius and the equatorial radius, okay, but the difference is so small that we can safely approximate, we can safely assume that this earth is a sphere. All right, okay. So what I will write down here, तो इस v के बदले हम क्या लिखेंगे बेटा? यहाँ पर इसके बदले हम लिख सकते हैं बेटा 4/3 pi r cube. All right, 4/3 pi r cube. Okay, so concentrate here. Okay, 4/3 pi r cube. Now next what I'm going to do is simply this, that I will substitute the value of this m here in the equation number first, so that we'll get one more equation for the acceleration due to gravity. And what is that? Equal to g divided by r square. ठीक है ना बेटा? बोलो बेटा mass के बदले क्या लिखेंगे? This rho, that is density into volume, so rho multiplied by 4/3 pi r cube, because we know that the volume of the sphere is equal to 4/3 pi r cube. All right, okay, so r square is going to cancel with the r square, so बचेगा क्या बेटा? 4 divided by 3. Let me first of all write down the constants. 4 divided by 3 pi multiplied by then g, then multiplied by these variable quantities, and what is that? Rho multiplied by r. Okay, so this is the acceleration due to gravity. All right, okay, so this acceleration due to gravity into the density. Directly the question can be simply asked like this: what is the acceleration due to gravity of any planet, for example of the earth, in terms of density and radius? So direct question you can expect from here. Or for example the question can be like this: put the value, get the answer type. Simply density of a planet is given to you, like for example 1000 kilogram per cubic meter. Let's suppose a radius of a planet is given to you, and you are supposed to calculate acceleration due to gravity. So this is the equation for you. This is the equation for you. Okay, so this is our equation number second. Moreover, what's important here is this, is the dependence of the g on the different parameters. Okay, so number one, what I can write is this: g is proportional to m by r square. This is highly important. It is important because continuously the questions are asked of this type, that for example there are two planets, one is planet A, another is planet B. Mass of planet A is given, mass of planet B is given, radius of planet A is given, radius of planet B is given. You are supposed to calculate the ratio of the acceleration due to gravity. Or for example, the acceleration due to gravity of the one planet is given, and then comparing these parameters, you are supposed to calculate the acceleration due to gravity of another planet. All right, we'll be doing questions on this. Okay, then one more important thing is this: acceleration due to gravity is proportional to density multiplied by r. ठीक है ना बेटा? Okay, so whenever for example mass and radius is given to you, whenever you see the mass and the radius in the problem, so it must remind you of this very equation. ठीक है ना बेटा? If for example the density and radius is given to you, then you must be using the equation number second. ठीक है ना बेटा? Okay, so highlight this, it is highly important, really important. ठीक है ना बेटा? Okay, so let's do a couple of questions on this. So that you will come to know how the questions are asked on this. ठीक है ना बेटा? Okay, so example number one is simply like this. For example, there are two planets. कितने planets है बेटा हमारे पास? Suppose there are two planets like this here planet A and this another planet. For example, it's like this planet B. All right, so this planet A, this planet B. ठीक है ना बेटा? Its radius is given. For example, its radius is twice r. Radius of this is given, that's equal to r. ठीक है ना बेटा? And mass of this, let's suppose that its mass is given twice m. Its mass is twice m. Its mass is something like, suppose 3m. It's highly dense planet and its mass is 3m. All right. Okay. Now what's given is this. Suppose that the acceleration due to gravity of this A is equal to, suppose it's equal to g. Let's suppose it's equal to g. You can have acceleration due to gravity on the surface of planet A is g, and you are supposed to calculate what will be the value of acceleration due to gravity on the surface of planet B. All right. Okay. So first of all, you see what is given to us. What is given to us? हमारे पास क्या दिया गया बेटा? हमारे पास mass and radius दिया गया है बेटा. ठीक है ना बेटा? So which is the equation you will be using? You will be using the first equation. All right. Because the first equation involves what? That includes what? This mass and acceleration, mass and radius. So g is equal to what? That's equal to gm by r square. Or safely what you can write is this. Safely what you can write is this. आप यहाँ पे क्या लिख सकते हो बेटा? You can simply write down like this. G is proportional to m by r square. G is proportional to m by r square. ठीक है ना बेटा? Proportional to m by, so directly proportional mass of planet, inversely proportional square of the radius. Square of the radius. ठीक है ना बेटा? So that means, what does that mean? That means this acceleration due to gravity gb divided by GA will be equal to this. It will be equal to directly proportional mass, so it will be equal to MB divided by MA, because directly proportional. ठीक है ना बेटा? Multiplied by the inversely proportional square of distance, so it will be like this. It will be here RA square divided by RB square. ठीक है ना बेटा? RA square divided by RB square. All right. Now you see what is the mass of B planet and what is the mass of planet A. So this is 3m, this is 2m. 3m by 2m is simply equal to 3 by 2, or the ratio is simply 3 by 2. ठीक है ना बेटा? Then multiplied by. What about RA and RB? RA is equal to 2 R and RB is equal to R. So I will write down here 2 divided by 1 whole square. ठीक है ना बेटा? Okay, 1 2 will cancel with 1 2, 2 3s are 6. So the ratio will be simply equal to 6, or the answer will be 6. So what you are supposed to calculate is GB. So GB will be equal to 6 times G. That's it. GA. So that's equal to. So this answer. ठीक है ना बेटा? Easy problem, okay. And the same similar pattern. The questions of the similar pattern are asked. Either you are supposed to calculate the ratio of the acceleration due to gravity, or the acceleration due to gravity of the one planet is given to you, and then you are supposed to calculate the acceleration due to gravity of another. But you just take care of one thing, and that is which parameters are given to you. All right, ठीक है ना बेटा? So you must take care of that, okay. So next question, यहाँ पे ध्यान दीजिए बेटा. So next question, what I am going to do is this. Another example is here. We have example number 2. यहाँ ध्यान दीजिए बेटा. Okay, so what I will be doing is that we will be calculating the ratio of the acceleration due to gravity, and then we'll be seeing what is the error, what is the mistake you can do, and what can be the answer from there, and that can be the one option. ठीक है ना बेटा? So the examiner can be playing with your brain. तो यहाँ ध्यान दीजिए बेटा. So for example, here we have, these are two planets. These are two planets. This planet A and this is planet B. All right. What is given is that their density is same. Density is same. That means density of A and density of B is exactly same. ठीक है ना बेटा? इसका radius दिया गया बेटा. For example, radius of A that is equal to, let's suppose it's equal to R, and radius of B, for example, it's given, it's equal to twice R. What's it? It's equal to twice R. ठीक है ना बेटा? Radius is given to you. Then you are supposed to calculate this GA is to GB. You are supposed to calculate the ratio of the acceleration due to gravity, isn't it? You are supposed to calculate what ratio of acceleration due to gravity. यहाँ ध्यान दीजिए बेटा. यहाँ ध्यान दीजिए बेटा. For example, what you can do is this. You can make an error here. You will say that acceleration due to gravity is equal to gm by r square. So it's proportional 1 divided by r square. ठीक है ना बेटा? So what you can do is this. G is proportional to 1 divided by r square. ठीक है ना बेटा? So what you will do is this. You will write down like this. Ga divided by gb quickly. ठीक है बेटा? That's equal to rb divided by ra whole square, or b divided by ra whole square. All right. Now what is the value of rb? That's equal to 2r. ra किसके बराबर है बेटा? r and r will cancel. 2 का square बनेगा बेटा 4. So the answer will be equal to 4:1. ठीक है बेटा? Answer क्या निकलेगा आपका? 4:1. Option number A होगा 4:1. ठीक है बेटा? And then you will take it, and hence the answer is incorrect. The reason is that this equation is true only mass is constant. ठीक है ना बेटा? So what is the this approach is it is completely incorrect approach. ठीक है ना बेटा? ठीक है बेटा? So how we do it rightly? यहाँ ध्यान दीजिए बेटा. So G is proportional to what? Rho multiplied by R. ठीक है बेटा? And G is proportional to m by r square. ठीक है बेटा? If for example it is given to us that the mass of the two planets is constant, then in that very case obviously G is proportional 1 by r square. And if for example it is given that density is constant, in that very case G is directly proportional to R. ठीक है ना बेटा? तो यहाँ पर हमें कौन सी इक्वेशन लगानी है बेटा? We have to use the first equation. ठीक? So what I will do is I will simply write down this. G is directly proportional to R. All right. So what I can write is this. GA is to GB. GA is to GB will be equal to RA is to RB. ठीक है ना बेटा? RA is to RB. All right. अब बोलो बेटा RA किसके बराबर है बेटा? R के बराबर. So this will be equal to R is to 2R. ठीक है ना बेटा? r and r will cancel, so its answer is 1:2. जो आपका D पार्ट रहेगा बेटा, D ऑप्शन रहेगा, so the answer is 1:2 and the answer is not 4:1. ठीक है ना बेटा? तो करेक्ट आंसर हमारे पास क्या है बेटा? That's equal to 1:2. Okay, so I'm sure आपको ये प्रॉब्लम अच्छी तरह से समझ में आई होगी and what's the error you can make. ठीक है बेटा? Okay, so try to protect yourself from the error. What you will memorize is this: is proportional rho into r, is proportion m divided by r square. Not only is r is important, but what's important is that what's constant out of the two parameters. All right, ठीक है ना बेटा? Okay, great. So यहाँ तक I think that I expect that यहाँ तक आपको अच्छी तरह से समझ में आया होगा. ठीक है ना बेटा? Okay, now let's switch to another topic. And the topic here we'll be discussing is that how the acceleration due to gravity varies. ठीक है ना बेटा? Okay, so next topic हमारे पास क्या है बेटा? That's variation of acceleration due to gravity. Okay, so let's get started. Variation of acceleration due to gravity. All right? Okay. तो नेक्स्ट टॉपिक हमारे पास ये है बेटा, वेरिएशन ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी. ठीक है ना बेटा? जो ये एक्सेलरेशन ड्यू टू ग्रेविटी है बेटा, its value is equal to gm by r square and then it is in turn equal to 9.8 meter per second square on the surface of earth. ठीक है ना बेटा? But its value is not a universal constant. Capital G is a universal constant whose value is 6.67 and 10 power minus 11. Universal constant implies that wherever you go, the value of the capital G is not going to change. It's going to stay same. It's going to remain constant. ठीक है ना बेटा? But what about small g? Small g does change. ठीक है ना बेटा? Now what are the parameters? What are the physical quantities on which the value of small g depends? Or what are the parameters which can change the value of the small g? ठीक है ना बेटा? Number 1, acceleration due to gravity decreases with the height. It changes with the height. Acceleration due to gravity changes with the depth. You go from the surface of earth upwards, acceleration due to gravity will change. You go from surface of earth towards the center of earth, acceleration due to gravity is going to change. ठीक है ना बेटा? And then you know that the earth is not a perfect sphere. The equatorial radius is more compared to the polar radius. So that means as you move from the poles to the equator, or from the equator to the poles, the acceleration due to gravity, the value of the acceleration due to gravity, again it will not stay same. It's going to change. ठीक है ना बेटा? And then acceleration due to gravity also changes with the rotation. For example, suppose that if earth rotates fast, what will happen to the acceleration due to gravity? If earth stops rotating, what will happen to the acceleration due to gravity? ठीक है ना बेटा? Okay, so on and so forth. Okay, so we'll be discussing that one by one. So first of all, what is our topic is that how the acceleration due to gravity varies with the height. ठीक है ना बेटा? So this is our first topic. ठीक है बेटा? So first topic is this, that how the acceleration due to gravity varies with the height, then with the depth, then due to the shape, and then due to the rotation. So one by one we are going to discuss all these. All right? Okay. तो यहाँ ध्यान दीजिए बेटा. Okay. So I'm sure you are focused. Okay. I'm sure you are focused. यहाँ ध्यान दीजिए बेटा. Okay. So stay focused. ठीक है ना बेटा? यहाँ पर आप ध्यान दीजिए बेटा. Okay. So we'll be killing it. Okay. तो यहाँ ध्यान दीजिए बेटा. So next, what is the next now is that variation of acceleration due to gravity. So A parts with height. How the acceleration due to gravity varies with the height. ठीक है ना बेटा? With height. Okay. Easy part है बेटा. कोई इसमें rocket science नहीं है बेटा. So simply for example here we have, this is earth. What is this? Earth. This is the acceleration due to gravity. This is the acceleration due to gravity. ठीक है बेटा? This acceleration due to gravity on the surface of earth, and this is at some height. So this here this is equal to h. ठीक है बेटा? Okay. So this the value of acceleration due to gravity here is g, and the value of acceleration due to gravity here at this very point is g subscript h. Subscript h implies that acceleration due to gravity at a height of h from the surface of earth. All right? Okay. यहाँ ध्यान दीजिए बेटा. So what I will write out here is this, that acceleration due to gravity at g is equal, at the surface is equal to gm by r square. ठीक है ना बेटा? At this very it is gm by r square. Okay. Now acceleration due to gravity at height h is equal to what? That's equal to gm divided by r plus h whole square. All right? ठीक है ना बेटा? Simply what I will do is that I will replace this r by r plus h. So that the acceleration due to gravity is what? Gm divided by r plus h. अब इस gm के बदले क्या substitute कर सकते हैं बेटा? So gr square. So the acceleration due to gravity at height h will be equal to gr square divided by r plus h whole square. ठीक है ना बेटा? So this gives you acceleration due to gravity with the height h. Okay. Now if you see clearly, in the denominator there's r plus h. The numerator there's r square, so that means this denominator is greater compared to the numerator. So what does it mean? It means that this implies that the acceleration due to gravity at height h is less compared to acceleration due to gravity on the surface of earth. ठीक है ना बेटा. So that means as you move upwards, as you move from the surface of the earth, the acceleration due to gravity is going to change, and that's going to decrease. ठीक है ना बेटा. Obvious reason, because as you move from the surface of earth, the separation between the center of earth and the center of that particle, that's increasing. When that's increasing, force is decreasing, and when the force will decrease, obviously the acceleration will decrease. All right. So this is the acceleration due to gravity. तो ये आपको याद रखना बेटा. ये result highly important. G(r) squared by r plus h whole square. ठीक है बेटा. And then there's special case here. Then there's special case, and that special case is, for example, this h is very small compared to r. For example, like this, you are supposed to calculate the value of acceleration due to gravity at the top of Mount Everest. ठीक है ना बेटा. The highest place on the earth, at the top of Mount Everest, you are supposed to calculate what acceleration due to gravity. लेकिन बेटा अगर आप देखोगे what is the height of the Mount Everest, you will see that it's approximately 8 kilometers, isn't it? Approximately 8 kilometers. All right. Okay. Then what about the radius of the earth? वो कितना होता है बेटा? वो कितना होता है? वो होता है बेटा 6400 kilometers, 6400 kilometers or 6400 kilometers. All right. Okay. Then for example, let's suppose that you are supposed to calculate value of acceleration due to gravity from this very equation. यहाँ r के बदले आप क्या लिखोगे बेटा? 6400. h के बदले क्या लिखोगे बेटा? 8. Now the 6400 plus 8, the calculation becomes a bit difficult. The calculation becomes a bit difficult. ठीक है ना बेटा. Okay. So that's why we are studying this case that h is very small compared to r. ठीक है ना बेटा. In that very case, acceleration due to gravity will not be deriving this here. Will not be deriving. It's time consuming. ठीक है ना बेटा. Actually, what you have to do is that you have to play with this mathematical equation and then apply the binomial theorem. And in that binomial theorem, you have to neglect the higher powers of h by r. Okay, and then finally, after doing that, you will end up with this equation that is equal to g into 1 minus 2h divided by r. 1 minus 2h divided by r. ठीक है ना बेटा. But this equation जो बेटा ये equation है ना, this equation is true only if h is very small compared to r. It is true only if h is very small compared to r. What I mean by saying that implies, suppose that a question is asked to you in the NEET or in the JEE. The question is like this. Calculate the value of acceleration due to gravity at a height equal to the rates of earth. Now obviously you cannot neglect the rates of earth compared to the rates of earth. You cannot neglect that. So safely what you can do is that you can use this equation. तो यहाँ करना क्या है बेटा? h के बदले आप r लिखोगे. So r plus r is equal to r and all that. Then you can play with this equation. We'll be doing those questions as well. ठीक है ना बेटा? But if for example the question is like this, calculate the value of acceleration due to gravity at a height of 1 kilometers, at a height of 2 kilometers, at a height of 10 kilometers. Safely what you can do is this, h is very small compared to r. You will be using this equation, not this equation. ठीक है ना बेटा? Okay. So how many equations we have? Exactly, we have 2 equations for the acceleration due to gravity with the height. What I will do next is that I will be summarizing those 2 equations. एक equation हमारे पास ये है बेटा, gh is equal to what? That's equal to gr square divided by r plus h whole square. ये बेटा आपके पास है generalized equation. This is always true. Okay. And then one more equation there, gh is equal to g multiplied by 1 minus 2h divided by r. ठीक है ना बेटा? But this equation is true only if h is very small compared to r. Second equation is true only if height is very small compared to the radius of the earth. ठीक है बेटा? So this is the law we have with us. Okay. So these are the equations we have with us. ठीक है बेटा? Moreover, आप एक चीज और यहाँ पे ध्यान रखेंगे बेटा. Suppose that the question is not asked on the acceleration due to gravity, on the variation of the acceleration due to gravity with the height, but the question is asked on the variation of weight. ठीक है बेटा? Variation of weight. You know that this weight is equal to m multiplied by g, and then you know other thing that if for example a particle is taken from the surface of earth to some height h, its mass is not going to change, its mass will stay same, but the acceleration due to gravity will change. When the acceleration due to gravity will change, then the weight will also change, and the weight will change exactly in the similar fashion as that of the acceleration due to gravity. It will exactly change in the same way as the acceleration due to gravity is changing. All right, ठीक है ना बेटा? Okay, तो वो आप ध्यान रखेंगे बेटा. Okay. So here we'll be doing a question here. यहाँ ध्यान दीजिए बेटा. Okay. So we'll be doing an example here, a simple example, and you will see that this question, though simple, but has been repeated almost 3-4 times in the previous questions. We'll be later on doing the previous question, and there you will see that yes, of course, this question has been repeated. ठीक है ना बेटा? Okay. तो आप यहाँ ध्यान दीजिए बेटा. Example is simply like this. That for example h is equal to r. ठीक है बेटा? At height equal to the radius of earth, you are supposed to calculate what is the value of acceleration due to gravity. So simply what you will do is this: you are supposed to calculate what is the value of this gh, what is the value of acceleration due to gravity at height equal to the radius of earth. ठीक है ना बेटा? Okay. तो यहाँ ध्यान दीजिए बेटा. Okay. So you have to use the first equation, not the second equation. If for example you will use the second equation, तो आपके पास क्या आएगा बेटा? h के बाद आप लिखोगे r and r will cancel. 1 minus 2 is equal to -1, तो आंसर आएगा बेटा आपका -g. Option A can be -g in order to create confusion among the brain of the students. ठीक ना बेटा? Okay, तो आंसर -g नहीं आएगा बेटा. First of all, acceleration due to gravity is not negative. Its value simply plus 9.8 meter per second square. ठीक है ना बेटा? Okay, तो यहाँ आप ध्यान दीजिए बेटा. So acceleration due to gravity, we will be using the first equation gh is equal to what? It's equal to gr square divided by r plus h. और बेटा r h will be replaced by r, so it will be here r whole square. All right, तो यहाँ आप ध्यान रखेंगे बेटा r plus r is equal to 2, r 2 square is equal to 4, r square is going to cancel with r square, so the answer will be simply equal to g by 4. And what about the weight? Whatever will happen to the acceleration due to gravity will happen to the weight, so it will be also equal to w by 4, where w is the weight of the object on the surface of Earth. ठीक है ना बेटा? And what about the mass? And the height h? That is going to stay same. The mass is not going to change. Acceleration due to gravity changes, because of which the weight of the object changes. All right, ठीक है ना बेटा? Okay, ठीक. So let's move ahead. Then this can be replaced, like for example, h is equal to r, h is equal to 2r, and so on and so forth. Okay, so we can have one more equation, and that's like this. For example, it's given to you if h is equal to n times r. ठीक है ना बेटा? What about the acceleration due to gravity at height h? This can be a generalized question. ठीक है बेटा? So simply again we will use this gh is equal to gr square divided by r plus h whole square. h के बदले हम लिखेंगे बेटा nr whole square, isn't it? ठीक है बेटा? What you can do is that r square get to common, and then r square is going to cancel with the r square. So what we are left with is this. यहाँ पे आएगा बेटा g divided by नीचे आएगा बेटा n plus 1 whole square. ठीक है ना बेटा? So this is your acceleration due to gravity. All right, ठीक है बेटा? Okay, तो आपको ध्यान क्या रखना बेटा? यहाँ ध्यान दीजिए बेटा. Okay, so I will tell you an interesting thing, and that is how many equations we have. We have of course 2 equations. ठीक है बेटा? अगर आपके पास बेटा क्वेश्चन आएगा on the variation of acceleration due to gravity, अगर बेटा क्वेश्चन आएगा that question like this, acceleration due to gravity on the surface equal to g, what is the acceleration due to gravity at height this and that, तो एक बात आप याद रखो बेटा. Okay, take it for granted that the question will never be asked on this. इस पर बेटा क्वेश्चन नहीं आएगा. इस पर अगर क्वेश्चन आ सकता है बेटा, वो ये आएगा that how the acceleration due to gravity varies with the height if h is very small compared to a direct relation. Put value get answer type question इसमें नहीं आएगा बेटा, नहीं, बिल्कुल भी नहीं आएगा बेटा. For example, this h is equal to 2 kilometers, r is equal to 6400, then the examiner knows that the student is unable to do this problem. Okay, it becomes a bit difficult calculation. ठीक है ना बेटा? Bit of tricky calculation. So इस पर बेटा put value get answer type question नहीं आएगा. इस पर अगर question आएगा बेटा, वो ये आएगा what is the value of acceleration due to gravity at height h? What is the change of acceleration due to gravity as the particle is taken from surface of Earth to height h? ठीक है बेटा? What is the fractional change of acceleration due to gravity? ठीक है ना बेटा? We'll be discussing that later on जब हम ये पढ़ेंगे बेटा with depth. Okay? ठीक. Okay, so I'm sure यहाँ तक आपको अच्छी तरह से समझ में आया होगा बेटा. Okay, so next जो हमारा टॉपिक है बेटा, that is acceleration due to gravity with the depth. Okay, तो जो हमारे पास बेटा second factor, and what's that? That's with depth. So here I will write down with depth. Okay, so let's switch to that with depth. Okay, ठीक. So again what I will say is that the acceleration due to gravity is maximum at the surface of Earth. It's maximum at the surface of Earth. आप याद रखिए बेटा, it's maximum at the surface of Earth. Okay, all right. तो यहाँ आप ध्यान रखो बेटा, acceleration due to gravity with depth. Okay, so for example here we have this is the surface of Earth. Okay, now you know that there are 2 points. एक point हमारे पास ये है बेटा on the surface of Earth. What's the acceleration due to gravity here? That's equal to g. All right. Then here this is the center of the Earth point. Oh, ठीक है बेटा? Okay, then with depth. For example here we have point acceleration due to gravity at this very point is d. ठीक है बेटा? gd. And this is the depth d. This depth d. ठीक है ना बेटा? From here to here the depth is d. Okay, so that means obviously यहाँ से यहाँ कितना distance है बेटा? यहाँ से यहाँ बेटा distance है r, isn't it? r radius. जो ये वाला distance है बेटा वो कितना है? वो है बेटा obviously r minus d. ठीक है बेटा? That's equal to r minus d. All right. Okay. So let's try to calculate the value of acceleration due to gravity. Again, we'll not be going with the mathematical derivation. We'll not be going to derive it. I will be directly writing down the equation. Gd is equal to beta acceleration due to gravity with the height is equal to what? That's equal to 1 minus 2h by r multiplied by g. There's a similar kind of equation with a small difference, and that's like this 1 minus d divided by r multiplied by g. I'm not going to derive this equation. ठीक है ना बेटा? Just memorize this. And moreover, जो बेटा acceleration due to gravity है ना बेटा with height, there are 2 equations. Okay, one is gr square divided by r plus h whole square. Another is g into 1 minus 2h divided by r but the second equation is true only if h is very small compared to r. In this equation we have just one equation, okay, whether this d is very small compared to r or d is comparable to r, whatever the situation is, in all circumstances there is one equation. D is given to you 1 kilometer, use this equation. D is given to you r by 2, use this equation. All right, ठीक है ना बेटा, but in case of height you will have to take care of that, okay, you will have to take care of that, ठीक है ना बेटा, okay. So this is GD, that's equal to 1 minus D divided by R multiplied by G. All right, ठीक है ना बेटा. तो यहाँ पर कुछ points, important points है बेटा. Number one is that this GD is less compared to G. So what does that mean? That means the acceleration due to gravity decreases with the depth as well, ठीक है बेटा. Number second is that जो acceleration due to gravity on surface है ना बेटा, on surface. So here I will write down on surface. What is the value of acceleration due to gravity? What is the value of acceleration due to gravity? That's equal to gm by r square, or that's equal to 9.8. This is the maximum value of the acceleration due to gravity. This is the maximum possible value the acceleration due to gravity can have, okay. ठीक है बेटा. Then one more point is that if for example at the center of earth, ये भी बहुत अच्छा point है बेटा, at center of earth, what is the value of this d? Obviously ये d कितना होगा बेटा, ये d होगा बेटा r के बराबर. Then this d will be equal to r. So what is the value of acceleration due to gravity? बोलो बेटा, that's obviously equal to 0, okay. So acceleration due to gravity at the center of earth is equal to 0. What about the weight? This implies that the weight of the object will be obviously equal to 0, ठीक है बेटा. This is called as condition of weightlessness at the center of earth, ठीक है बेटा. At the center of earth, what is the acceleration due to gravity? That's equal to 0, ठीक है ना बेटा. So when that's equal to 0, so obviously what will be weight? That will be 0. What will be mass? That will be not equal to 0. Mass is not going to change with the height and with this and that. All right, ठीक है बेटा. So we are done with this with the depth and with this, ठीक है बेटा. Okay, so let's do a question on this. Let's do an example on this. The example is simply like this. यहाँ ध्यान दीजिए बेटा. Example is simply like this. That if d is equal to r by 2, what is the value of acceleration due to gravity? What will be gd? ठीक है बेटा. So simply you have to use one equation, that is gd is equal to g multiplied by 1 minus d divided by r, ठीक है ना बेटा. Okay, so obviously d by r किसके बराबर है? 1 by 2. So it will be equal to g into 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. Answer is simple, g divided by 2. So this is the value of acceleration due to gravity with the depth, ठीक है बेटा. Okay, ठीक. Okay, next question आपके पास बेटा ये है. It is an important point and the question as well, and that's like this. Plot GD, that's acceleration due to gravity due to depth versus D. You have to plot the graph between GD versus D. ठीक है बेटा, versus D. Okay, so versus D you have to plot the graph. Okay, wait a moment. Okay, so let me rewrite it here. Plot, what it plot is this. GD versus D, ठीक है बेटा. All right, ठीक. Okay, यहाँ ध्यान दीजिए बेटा. So simply what I will write down is this. For example, simply I will plot the graph straight away. So यहाँ पर बेटा acceleration due to gravity and this here D, ठीक है बेटा. When D is equal to 0, this is the surface, ठीक है ना बेटा. When D is equal to R, this is the center. On surface, acceleration due to gravity is equal to G, which is maximum. At center, so this is the center of Earth. This is center. And what about this point? This is surface. So as you move from surface to center, acceleration due to gravity decreases and decreases linearly. On surface, acceleration due to gravity is maximum. At center of Earth, acceleration due to gravity is 0. It decreases linearly. Like this. ठीक है बेटा, it decreases linearly like this. Okay, so it decreases like this. ठीक है बेटा. If you see this equation, it's a linear equation. GD versus D, a linear equation. So like this. Okay, we're not going to in the details of this. तो आप ये ग्राफ याद रखोगे बेटा. Okay, next point, important, highly important. यहाँ ध्यान दीजिए बेटा. Okay, now we know that acceleration due to gravity कहाँ पर maximum बेटा? At the surface. Exactly. At the surface it is maximum. ठीक है ना बेटा. And with height, what happens to acceleration due to gravity? Obviously it decreases. With depth, what happens to acceleration due to gravity? Obviously it decreases. ठीक है ना बेटा. Okay, but the next question is this: is the rate of change of acceleration due to gravity with depth and with height same? Is that same or not? What I need to say is this. यहाँ ध्यान दीजिए बेटा. So for example, here we have Earth. An important point here. This is center of Earth. ठीक है बेटा. Now I'm going to mark 2 points. यहाँ ध्यान दीजिए बेटा. So here we have this point A, this point B, and this is surface, and this for example point C. तो कितने points है बेटा? 3 points है. ठीक है बेटा. Okay. these distance are given to you. Let's suppose that this is given, this is 2 kilometers from the surface of the earth. This distance is given to you, again 2 kilometers from the surface of earth. That means you are going upwards 2 kilometers from surface of earth, 2 kilometers deep, ठीक है बेटा, into for example a ton, okay, that's 2 kilometers. Now the question is like this: compare the acceleration due to gravity, or write down the acceleration due to gravity at point A, at point B, at point C in decreasing order. In decreasing order, ठीक है बेटा. तो ऐसे कर लोगे बेटा. क्या आप सोचोगे? With the height acceleration due to gravity decreases, with the depth acceleration due to gravity decreases, that means GA, GB will be less, GC will be greater. You'll write down quickly like this. You'll get tempted by this question. So GC is greater than GA is equal to GB. A completely wrong answer. Completely wrong answer. ठीक है ना बेटा? The reason is that acceleration due to gravity, it decreases. It does decrease. It decreases with height. It decreases with depth. No doubt about that. But the rate of acceleration due to gravity with the height and with depth is not same. It's not same. ठीक है ना बेटा? Okay. So यहाँ आप एक point याद रखोगे बेटा. यहाँ आप एक point याद रखोगे बेटा. That is this. That is this. That rate at which the acceleration due to gravity, that's like this dg. This is the variation of acceleration due to gravity with height. With height. ठीक है ना बेटा? It's equal to 2 times the rate of change of acceleration due to gravity with depth. With depth. Here I will write out it d, capital D. Where capital D is the depth. ठीक है ना बेटा? ये point आप याद रखोगे बेटा. That rate acceleration due to gravity, it varies with the height. The reason is this. यहाँ ध्यान दीजिए बेटा. यहाँ ध्यान दीजिए बेटा. Okay. So let me write down here the equations. 2 equations. A couple of equations. One equation we have is this. What is the value of GH? It's equal to 1 minus 2H divided by R multiplied by G. All right. Okay. So it's equal to this. ठीक है ना बेटा? And what about this GD? It's equal to what? 1 minus D divided by R multiplied by G. Okay. So acceleration due to gravity decrease with height, decrease with depth, decreases more rapidly. 2 यहाँ पर है बेटा, decrease more rapidly with the height and decrease less rapidly with the depth. ठीक है बेटा? So इसका correct answer क्या बेटा? इसका correct answer. So correct answer is like this. Correct answer ये है बेटा आपके पास. Then acceleration due to gravity for sure at C is maximum. Then it decreases more rapidly with the height and decreases less rapidly with the depth. तो यहाँ पर इससे कम होगा बेटा, greater than GB, greater than GA. So this is the correct answer. This is the correct answer. ठीक है ना बेटा? और जो ऊपर वाला आंसर है बेटा वो incorrect है. ठीक है बेटा? So this is our incorrect answer. तो incorrect answer है बेटा, ये incorrect answer. ठीक है ना बेटा? So important point here, okay? And then the question can be like this. इस पर भी question आ सकता है बेटा. Suppose that acceleration due to gravity at some height. ठीक है बेटा? At some height equal, suppose its value is given something. Its value is given. ठीक है ना बेटा? Okay. ठीक. So for example, it's like this. Suppose acceleration due to gravity at this point is G1. Suppose like this. Let me write it down here. यहाँ ध्यान दीजिए बेटा. Okay. So an important concept. ठीक है बेटा? Suppose that this is equal to D and this is equal to H. D and H. ठीक है बेटा? यहाँ पर acceleration बेटा, for example, suppose that it's equal to G1. यहाँ पर बेटा acceleration G2. ठीक है ना बेटा? Given to you that G1 is equal to G2. Another important example. ठीक है बेटा? Question आ सकता है बेटा. Acceleration due to gravity at point 1, at point 2 is same. Okay? Now, next, what is the relation between H and D? What is the relation between H and D? Relation between H and D. ठीक है ना बेटा? So simply what you can this G1 के बदले क्या लिखेंगे बेटा? 1 minus D by R multiplied by G. G2 के बदले height वाला 1 minus 2H by R multiplied by G. G and G will cancel. 1 and 1 will cancel. Minus minus cancels. R and R will cancel. Simply answer ये निकलेगा बेटा that D is equal to 2 times H. ठीक है बेटा? And if for example suppose that H is given 1 kilometer, D will be 2 kilometers. D is 1 kilometer, H will be half kilometer. That's it. तो ऐसा question भी आ सकता है बेटा. Highly important. All right? ठीक है बेटा? Okay. Then next. Do we have any time? It is 40. Done? Okay. Okay, dear students, we must stop here. ठीक है ना बेटा? So we'll be with a new session tomorrow. ठीक है बेटा? Okay. So you take care of yourselves. Okay. And moreover, subscribe to our channel, that's Resonance Class Handwara. ठीक है ना बेटा? Okay. So you take care of yourselves.